Brew Mation is an automated all-grain home brewery system designed to allow the user to input a desired recipe through a touchscreen GUI and easily achieve consistent results with minimal effort. It is ideally suited to casual home brewers and experienced brewers alike. The original tank design called for a 3-container structure and utilized both gravity feed and pumping to transfer fluid between containers. These tanks were to be manufactured from laser-cut 20-gauge stainless steel. CAD files were created for the tanks, and JetCam was used to generate the G-code and optimize travel path for the laser CNC. The tanks were separated into 3 parts: sidewall, base, and lid. Any necessary cutouts for fixtures to be welded in were included. Sidewalls were formed and welded around the base of the tanks. Externally, fusion looked complete, but a leak in the purge line to the tank caused porosity to be introduced to the interior weld, making the tanks unusable. A new tank design set back the schedule considerably due to material constraints. Since it could no longer be gravity fed, more valves and pumps had to be added to accommodate the necessary flow. The original heating elements were too large to fit the new tanks, so smaller, inline heating elements were connected in parallel to achieve the necessary wattage. Setbacks in the manufacturing of the tanks limited us to testing the separate elements of the system individually. A triac solid-state relay was used to control the 120-volt heating elements through pulse width modulation. The duty cycle of the heating element was directly mapped through a proportional control loop to the delta between set point and current temperature. By using this method, temperature was maintained within plus or minus 1 degree Fahrenheit of set point value, over our time range for the mash cycle, which was between 45 and 90 minutes. Temperatures were verified with a digital probe thermometer throughout testing. Event-based timers triggered when set points are reached are used to monitor and control the stages of the brew cycle. Precise control of volume was achieved through the use of a voltage divider as an electronic float switch. By using this method, flow between containers could be controlled to deliver a specific volume once, or maintain a volume, both necessary operations for the mash and lautering cycle.
The requirements for the application requires that the user must be able to create, edit, and delete recipes. Only 6 variables of the saved recipes in CSV will send serial communication to microcontroller. The display of the current time and temperature will be shown during the brewing process received from the microcontroller. Here the user edits a recipe. Here we're calling it a new brew max. This recipe is edited and updated in the database, and all fields need to be filled out. Once it's updated, I'm going to delete this recipe, and you see that it's gone. Now we want to brew a recipe. We select one, press brew, the CSV file is created, and you can see the temperature and time remaining. And once we close out, I will show you this is the CSV file created. 6 variables to send to the microcontroller. Unfortunately, Glue-On JavaFX port has not solved their issue since their last update, which changes the packages and contents, making the Finish button with no action to create a project or import a project. This was heavily dependent on to export the application onto a device. So unfortunately, we had to go to plan B using Android Studio. Here's the current application from Android Studio implemented into a tablet. Recipes are on the left, the overview is on the right. Currently working on the Brew button to communicate serial port with the Arduino Uno, which a sample test was successful prior to creating this app with the tablet. This should be accomplished in the next couple of days.